Notice that embedded in the dust clouds are huge girders and entire sections of steel framing that are being hurled out of the building. The horizontal speed of some of the girders has been clocked at over 70 miles per hour. Some of these girders impale themselves in the sides of neighboring buildings. Some landed as much as 2 football fields away from the base of the tower. What could hurl heavy girders with such force and give them such speed? Some people have suggested that the weight of the tower crushing down on the girders caused them to flex, and they sprung sideways by a spring action. But we are not seeing isolated jumping girders. We are seeing a major fraction of the mass of the building, steel, concrete, office furniture, and the remains of human beings, reduced to small pieces of rubble and fine dust, and being explosively ejected in all directions. Bone fragments are found on the roofs of adjacent buildings. The bones were not crushed in the falling mass, or they would have been trapped in the debris pile. They were pulverized along with everything else and blown out in all directions. The NIST investigators have claimed that the top section of the building above the plane impact point came down like a pile driver, crushing the undamaged lower section of the building all the way to the ground. The top section of the building is, however, noticeably absent. There is nothing above the ring of explosions except for a fountain of debris. Can you see a pile driver?
Okay, let's stop it here. I think this is, when you've seen this video, there's no question left, in my mind at least, that explosives were used. And here you see the steel beams from 2 to 30 tons were thrown 100 meters away. And I don't know the exact weight of this one, but this is not a spring action of the steel beam. These are explosives. But there were other observations also done around the towers. So I showed you here a picture from where it shows the South Tower. This is around the 82nd floor, I think, where something is pouring out of the corner of the building. The South Tower is the 82nd floor, yeah, around that, yeah. And the point is that this is red-orange, what is coming out here. This is seconds before the collapse. Half a minute before the collapse of the South Tower. We have this strange observation. This is another video. There's no doubt that there is something going on, unusual going on here. And even NIST recognized that this has an orange glow, whatever came out of the South Tower, which means that it is not aluminum. Molten aluminum is white, like silver. It melts at 660 degrees, depending on the alloy. And so it might easily actually melt at an ordinary office fire. But this can only be iron, molten iron. This is the only metal which can account for this observation. And iron melts at 1538 degrees centigrade. And there is no way this temperature can be reached in an ordinary fire. If you have a stove at home or an old-fashioned stove, or you use it for burning wood in the cottage or whatever, it doesn't melt when there's fire in there. Iron doesn't melt under ordinary fire circumstances. So there's only one chemical reaction which actually can account for this observation. And this is called thermite. And this is not an insect with 6 legs from Africa. Or maybe you have
termites. Termites, yeah.
Nasty little beats. But this is a chemical reaction which actually was discovered by a German chemist called Hans Goldschmidt in 1893 and patented in 1898 because it's a very useful thing. It is a mixture, the old-fashioned, the simplest version of a thermite mixture is a mixture of pulverized, very finely divided aluminum and iron oxide, which is the chemical name for rust. So imagine you have used these two powders mixed. If you can get them to react, which is not that straightforward and easy, but if you can make them react The reaction is very violent. It produces elemental iron and aluminum oxide, but at the same time, tremendous amount of energy is released in the form of heat. So the iron coming out of this reaction has temperatures of 2,500 degrees centigrade and beyond. This can be very useful for welding. And thermite has been used for railway and tram rails welding for a long time, other purposes also. And iron workers know that there's something called thermite welding. But it can also be used to destroy other iron things. So it has a military application and has had so since the 30s in many different varieties. So thermite, a classical thermite, is not an explosive. An explosive works by pressure and by force, but thermite works by heat. It's an incendiary. And now I'll show you what thermite can do on a French car, and at the same time give you an impression of how we teach chemistry at the university.
This is thermite. It's a powdered mixture of iron oxide and aluminium, which when ignited burns at 2,500 degrees Celsius, which is very, very hot. This is car. It's been specially chosen to be destroyed because it's old, it's white, but more importantly, because it's French. The engine block is the densest part of the car. It's basically a huge lump of metal, and well, it's very hard to melt. Lucky then, the brainiacs have plenty of thermite, specially packed into the slow release mechanism of a garden flower pot. A big pile on the bonnet directly over the engine block should do the trick. Time to light the fuse and give this homage to French engineering the send-off it so richly deserves. The irreversible thermite reaction begins.
I should see what happens underneath the car. I'll go around down here.
Spraying molten thermite into the engine beneath. The devastation continues inside until finally a torrent of white-hot liquid metal pours out of the bottom, signaling the inevitable victory for thermite. A quick check confirms a clear path of destruction through the engine.
But you know the engine block, it's just a solid iron. And what happens with the poor flower pot, the modern iron is just going all the way through the block here. Now you might already has maybe thought of, if he thinks that thermite can destroy, has been involved in the destruction of World Trade Center, we have a problem, don't we? Because the molten iron actually goes downwards in a vertical. How can you ever destroy a vertical column with thermite? Well, this problem can be solved in many different ways. And now I'll show you a little device which you can buy if you, these are hard times. Maybe you need to get rid of the summer house while you're away, or even your own house if you need that, then you can buy. This is a commercial product, and in an advertisement, and it's very, very short. So I have to tell you what you're going to see. You're going to see this device which has thermite within. It's mounted horizontally in front of an iron bar, and there are two cables going on. It's ignited electrically, and I can tell you there is a little propellant. This is a chemical substance behind the thermite, which is blowing the thermite out on the iron bar. Watch out.
Ooh.
I think I touched something with my back here. This is nothing to